Right, Badr, everything is clear till now? All the topics that you have seen till now, if you have any questions, you can ask me while we are waiting for more students to join the session. If you have any questions, you can ask me in the meantime. Any questions, Badr? Do you have any questions regarding any of the previous lectures? If you have any questions, you can ask me. We have time. Okay, we have one more student joining in now. Who is this? Okay. Ibrahim, you have any questions before we start the lecture for today? While we are waiting for more students to join, let's wait for 2 or 3 minutes to see if more students will join. And in the meantime, if you have any questions, you can ask me. While we are waiting for the other students. Oh, he's logged out again.
السلام عليكم دكتور.
Walaikum assalam. Okay, you can hear me now? Alright guys, we are just waiting for some more students to join, okay? We'll wait another 1 minute and then we will start with today's lecture, okay? I'm just going to wait for 1 more minute to allow some more students if they're wanting to join. And after that, we will start our lecture. In the meantime, if you have any questions, you can ask me, guys, okay? Well, since you're not asking me any questions, I suppose you have no questions, right? So everything is clear. All the content that you have studied till now, all the lectures are clear, okay? Since there is no questions being asked, I just assume that everything is clear for you guys, okay? All right, let's start with today's topic, okay? It's a continuation of the previous lecture. And if you remember, we have been discussing about the 7-4 Hamming code, and what you see here is the generator matrix for the 7-4 Hamming code. And if you remember, the 7-4 Hamming code has the generator matrix for the 7-4 Hamming code has two parts, right? The first part to the left of this line is the identity matrix of size k, so we call that as I k, right? So this matrix here is the identity matrix of size k, and this matrix here is the, we call it as the parity matrix of size n minus k. So p n minus k, right? So we have the generator matrix which has two parts. The first part of the generator matrix is an identity matrix of size k. In the case of the 7-4 Hamming code, the value of k is 4, right? So the value of k is 4. So therefore, the identity matrix is a 4 by 4 matrix. That means it has 4 rows and 4 columns. So it's a 4 by 4 identity matrix, which is the first part of the generator matrix. And then you have the parity matrix, which is of size n minus k, in the sense that it has n minus k columns. So n minus k is 7 minus 4 is 3. So that means it has 3 columns. What's 1? That's 2. And that's 3 columns. So you have the parity matrix, which has uh, n minus k columns. And the identity matrix is k by k. That is 4 by 4 in this case. Okay. And in the previous lecture, I talked about uh, the different values that n and k can take for the Hamming code. So the value of n is given as 2 power m minus 1, and the value of k, we have to choose the value of k as 2 power m minus m minus 1. So when we are designing the Hamming code, we cannot choose the value of n and k as we like. Okay, the value of n and k for the Hamming code has to be chosen according to these conditions or these relations. Okay, n is given by 2 power m minus 1 and k is 2 power m minus 1. And in the last lecture we found out these values for different values of m. So we did it for m equal to 2. So for m equal to 2, you get n equal to 2 power 2 is 4 minus 1 is 3, and the value of k becomes 2 power 2 is 4 minus 2 is 2 minus 1, so 2 minus 1 is 1. So for m equal to 2, the values of n and k are 3 and 1 respectively. Okay, and for 7-4 Hamming code, you choose the value of m as equal to 3. So for 7-4 Hamming code, when you put m equals 3, you get n equals 7 and k equals 4. K equals 4, right? So for m equal to 3, we got the 7-4 Hamming code, which we have discussed in a lot of detail. The 7-4 Hamming code we have discussed in plenty of detail, the encoding, the decoding, everything we have discussed in the last 3 lectures. Okay, now what I want to discuss today is how do we choose this parity matrix. Okay, the identity matrix is very straightforward. We just have to have ones along the diagonal, everything is 0. But the parity matrix, we want to choose them in a specific way. So to illustrate that, I'm going to choose a different value today, that is the 3-1 Hamming code for m equal to 2. So when we have m equals 2, what do we get? We get the 3-1 Hamming code. So it's a 3-1 Hamming code. 3, 1 Hamming code. Okay, excuse me for my handwriting because I'm writing with my mouse, so it becomes a bit tricky. So it's a 3-1 Hamming code. Okay, so we have for m equal to 3, m equal to 2, a 3-1 Hamming code. That means we have the value of n to be 3 and k to be 1. And what is k? K is the number of information bits or the message bits, right? I, N, So I'll just write it as information bits info, and 3 is the total block length, right? So the total number of bits in the code word, we call it as the block length. So that's the block length. Oh. That means in a 3-1 Hamming code, we take one information bit and add two parity bits to make the code word of length 3. So with one information bit, we have two possible information messages, right? So the message is going to be either 0 or a 1. So that is our information bits. Because we have only one bit length for the information, we can have only two possible informations, that is two possible messages. The first message is message 0, or the second message is message 1, or the information 1. So we take this message, and when you perform the Hamming code, for the message bit we add two parity bits. So similarly, for the one message bit we are going to add two parity bits, so that we get a code word of length 3. So number 1, number 2, number 3. So it has 3 bits in length. So after the coding, the one bit of information becomes 3 bits of code word. Now the question is how to find the generator matrix for the 3-1 Hamming code. And we will use the same procedure as we did for the 7-4. If you see in the 7-4, the first part of the generator matrix, which you see here, is an identity matrix of size k by k, right? 4 by 4 in this case. In our case, for 3-1, today's example, the value of k is 1. So that means the first part of the generator matrix will be a 1 by 1 identity matrix. That means one row, one column. So the generator matrix for this, so G, the generator matrix, and just to keep it different from the 7-4, I will write it as the generator matrix for the 3-1 code, G31. Okay, so the first part of the generator matrix is an identity matrix of size k. The value of k here is 1. So it's a 1 by 1 identity matrix. That means it has only one row and one column. That means it has only one element. So, and that element is 1. Okay, we want it as an identity matrix because when we multiply the message with that identity matrix, we should get the same message, because we want a systematic code. A systematic code means the message bits appear unaltered at the beginning of the code word. So the first part of the generator matrix for the 3-1 Hamming code is the 1 by 1 identity matrix. So it's I1, right? It's 1 by 1. And then we need to have n minus k columns of the parity matrix. So n minus k in this case is 3 minus 1, that is 2 columns. So we need to add 2 columns here to this. So the 2 columns here we can add like this, right? So the generator matrix is going to have only one row and 3 columns. So it's only one row and 3 columns. That's column number 1, column number 2, column number 3. So now we have to choose the values for these 2 columns. So because there are 2 positions, we can have 4 combinations, right? The values that we can have, we can put there 0, 0. We can put there 0, 1. We can put it as 1, 0, or 1, 1, right? Because we have 2 bits here. For with 2 bits, we can get 4 possible combinations, which are shown here: 0, 0, 0, 1, 1, 0, 1, 1. Now let's see what happens if we put 0, 0. Okay, if we put here 0, 0 and we multiply with the message bit, it will become 0 into 1 is 0, 0 into 0 is 0, 0 into 0 is 0. That means the first code word will become 0, 0, 0. Similarly, the second code word will become 1 into 1 will remain 1, 1 into 0 will become 0, 1 into 0 will become 0. So with 0, 0, the code words will become 0, 0, 0 and 1, 0, 0, right? Similarly, if you put any of these numbers, any of these combinations, you will get different code words. But we are going to choose 1, 1 as our parity matrix. So I'm going to put here 1, 1. Why we choose 1, 1? It will become clear to you in just a few minutes. So when we put 1, 1, okay, that means we have chosen these two values for the parity matrix of the generator matrix. So when you put 1, what do you get? When you multiply the message 0 with this 1, 1, 1, so when you multiply message 0 with 1, 1, 1, so I'm going to multiply that. So take the message 0 and multiply with 1, 1, 1. What do you get? You'll get 0 into 1 is 0, 0 into 1 is 0, and 0 into 1 is 0. So the code word that you get is 0, 0, 0. So this will become 0, 0, 0. So you get this code word. Similarly, when you multiply the bit or the message number, message 1, with the generator matrix, which we have made it as 1, 1, 1, that becomes 1 into 1 is 1, 1 into 1 is again 1, and 1 into 1 is again 1. Okay, so this code word will become 1, 1, 1. Right? So now, if you remember, in the 7-4 Hamming code also, the minimum Hamming distance for the 7-4, for the 7-4 Hamming code, the minimum Hamming distance d min is equal to 3. And when we chose 1, 1 for the 3, 1 Hamming code as the parity matrix, if you see the Hamming distance between these two code words, the Hamming distance d is equal to 3. And that is the d min also, because we have only two code words. So the Hamming distance between them is 3. That therefore the minimum Hamming distance d min is 3. So we have achieved the same Hamming distance by choosing 1, 1 as our parity matrix. Okay, if we choose 0, 0 masalan, okay, if we had put 0, 0 in these two places, then the code words we would have got would be for 0, 0. Okay, let me write it like this. For 0, 0, the code words will be 0, 0, 0 and 1, 0, 0. And what is the Hamming distance between them? The Hamming distance between them is 1, right? Okay, what is the meaning of the Hamming distance? The number of positions in which the bits are different. So if you look at these two code words, the first bit is different, the second bit is same for both the code words, the third bit is also same for both the code words. Okay, so the difference is only in one position, so the Hamming distance is 1. Similarly, if you put 0, 1 and 1, 0 in these positions, you will get the Hamming distance as 2. We want the Hamming distance to be as high as possible, because that will make the error probability very small. Because if I want to change this code word to this code word 0, 0, 0, to make it 1, 1, 1, it has to change in three places. That means you need to have all the 3 bits to have error for it to be changed. Only, and when that happens, the coding technique will not detect the error. Okay, so we want to avoid that situation. We want to minimize the probability of the detection being failed. Okay, so to keep the Hamming distance as high as possible, you have now chosen 1 1 as the parity matrix elements for the 3 1 Hamming code. So by this way the Hamming distance is 3. If you choose any of the other three values 0 0 or 0 1 or 1 0, you will find that the Hamming distance is less than 3. For example, for 0 0 the Hamming distance is 1. For 0 1 and 1 0, if you put 0 1 and 1 0, you will get the, okay, let me do that also. So if you put if you multiply the message, okay, I'm going to put a line here. If you multiply the message with the parity matrix, with the generator matrix, which has the identity matrix in the front, followed by, say, we choose 0 1 for the remaining two positions, and when you multiply this you get 0 0 0. And for the bit 1, when you multiply it with the generator matrix, with, if you have chosen 1 0 1, then what will you get? You get 1 0 1. And if you compare the Hamming distance between these two, bit number 1 is different, bit number 3 is different, bit number 2 is the same in both, right? So bit 1 is 0 here, it's 1 here, so it's different. Bit 3 is 0 here, 1 here, so it's different. Bit 2 is 0 here and 0 here, no change. So the distance here in this case is 2. Okay, so the distance that you get here is 2. So when you choose 0 0, you get the distance as 1. When you choose 0 1 for these two positions, you get the distance as 2, and similarly for 1 0 you will find that the Hamming distance is 2. So we want to have the Hamming distance to be as high as possible, and for the Hamming codes the Hamming distance is, or the minimum Hamming distance is 3. So to maintain that property we have to choose this 1 1 as our elements of the parity matrix Pn minus k. Okay, now that's how you would choose the elements of the parity matrix, because if you see here the identity matrix is fixed, right? You just know, you need to know the size of the identity matrix. It has ones along the diagonal, all the other elements are zeros. But the parity matrix you have to choose in a specific way. That is where the design of the code comes into effect. Okay, and if you don't choose them properly, then your coding technique will not work properly. So as a rule, there are a couple of rules you need to follow when you choose these numbers for the parity matrix. The first rule is that in these numbers, like you have 1 1 1 here, 1 0 1 here, 1 1 0 0 1 1, right? The first rule is that you cannot have all zeros in the P matrix. You cannot have a row which is 0 0 0. Or for example, in this case, you cannot have a row which is 0 0. All 0 rows is mamnu. You cannot have all 0 rows, any row containing all zeros in the parity matrix, which we call as the P matrix, right? So 0 0 0 or 0 0, right? All zeros is not allowed. Number one. Number two, the second point is you cannot repeat the same row. If you have put one combination in one row, that same combination cannot be repeated in any other row. For example, 1 1 1, this appears only one time. You cannot have another place as 1 1 1. So no row should be repeated. That means every row should be distinct from the other rows. You cannot have a repetition of the rows. Okay, so that's the second point. So clearly in our 7-4 example also, we are following those rules. There is no row which is having all zeros, and there is no row which is a repetition of another row. Okay, so the row is not being repeated. And the third property that you have to remember is you cannot have, uh, you should have at least two ones in every row. Okay, You cannot have a row with less than two ones. So for example, the first row here has three ones. The second row here has two positions which are one. The third row also has two positions which are one. The fourth row also has two positions which are one. So the number of ones should at least be two. Can we change the order of the rows? I will answer that in a minute, okay? So the number of rows should be at least, the number of ones in every row, irrespective of the size. So we are doing it for 7, 4. Similarly, when you put m equal to 4, you'll get 15, 11. For all the cases, the number of ones in every row should be 2 or more, not less than 2. Okay, it should not be all zeros, and the row should not be repeated. Okay, so these are the three properties or conditions that you need to follow in choosing the rows of the parity matrix. Okay, now the question asked by one of the students is, can we change the order of the rows? Well, you can change the order of the rows in a specific way, not as you like. Okay, you cannot change the order of the rows as you like, but in a specific way. Okay, so therefore, for your course, what is that specific way in which you can change it? That depends on the design of the matrix. So do not do it. That will take some more advanced learning about linear algebra to understand how you can change the rows. Okay, so for your course, do not change the order of the rows, but for your information, I'm telling you what are the conditions we are supposed to follow when we are designing the parity matrix. So in your case, for our course, we will strictly follow this matrix as it is. Okay, because if you change it arbitrarily, then the coding technique will not work. Okay, for some cases it might work, for some it does not work, because there are rules as to how you can change the order of the rows. So therefore, do not change it, okay, because that is a slightly more advanced topic which involves some understanding of linear algebra and so on. So I don't want to go into those details because it is outside the scope of your syllabus, so we are not going to discuss that. But you should know what are the properties that are which are important. The first property is that it should not be all zeros. The second property is that it should have at least two ones in every row. And the third property is that the row should not be repeated. Okay, so these are the main properties that we have to do. Regarding the reordering, that depends on the design of the matrix itself, and there are some rules how to do it. So do not make any reordering in our course. Okay, strictly follow this procedure and this matrix, so that will keep you on the right track. Okay, so how we design the matrix. Okay, there's a lot of design. It's, these bits are not selected randomly as we like. Okay, there is some mathematics behind it. Okay, and we want to keep the minimum Hamming distance as high as possible. So if you remember in the 7-4 Hamming code, how many code words do we have? We have 16 code words in the 7-4 Hamming code, because with 4 bits we have 16 messages. For each message we have a code word. For 16 messages we have 16 code words, and between any two code words there is a different Hamming distance. Starting from 3, some code words have a distance of 4, some have 6, 5, 6, and the maximum that you get is 7. When do you get the maximum distance? You will get between all zeros and all ones, right? Because there are 7 bits. If I have a code word with 0, 0, 0, 0, 0, 0, 0, and another code word, the last one, which is 1, 1, 1, 1, 1, 1, 1, then the distance between them is 7. But the smallest between any two, if I take any two combinations and measure the distance, the smallest value that we get is d min, the minimum Hamming distance, which is 3. And for all the Hamming codes, irrespective of the value of n and k, we have 3, 1, we have 7, 4, and when you put m equal to 4, you get 15, 11, and so on. We did that exercise in the previous lecture. For all of them, the minimum Hamming distance is 3. Okay, so the minimum Hamming distance has an effect on the error detection and correction capability of the code. If you remember, the number of errors that can be detected. If we did that also in the previous lecture and even before that, the number of errors that can be detected is d min minus 1, right? That is the number of errors that we can detect with guarantee, right? Similarly, the number of errors that can be corrected is d min minus 1 by 2, and we take the floor value of it, right? The lower integer. If it's a fractional number, we take the lower integer. So this is the number of errors that can be detected, and this is the number of errors that can be corrected. So the number of errors that can be detected and corrected depends on d min. If we want more errors to be detected and corrected, that means we have to design a code word or a coding system for which the minimum Hamming distance d min is higher. So for the Hamming code, that is the limit. That is the possible combination. If you want to have more value for the daemon, then you have to design another type of code word, and we have other coding techniques called cyclic codes, convolutional codes, turbo codes. So there are many other coding techniques which are available, which are used in practice, but that is an advanced topic. So if you study masters in communication or something, you will come across those topics. Okay. For your course, we are just studying the fundamental topics about coding theory. So again, because the daemon value is very small here, the Hamming codes have very limited capability to detect the errors. So generally, the Hamming codes are used only for very good channels, okay, where the channel has less noise. When the channel has more noise, the Hamming code will be pretty much useless. So less noise means, for example, when you have some file stored on your computer hard disk, and when you're opening that file, the file that information is traveling through the cables to the through the board inside your computer, right, from your hard disk to your screen. It's coming through some connectivity, right? So those are all very clear channels without too much noise. So Hamming codes are used in that kind of a scenario. Okay, but in a real world communication where the signal is going outside your device, there, the more sophisticated coding techniques are utilized. Okay, right. I'm going to stop here for today, and I'm going to allow you the next round. We have, like, say, 25 minutes to discuss whatever questions you might have in all the topics that we have seen so far, right from the first lecture till today's lecture. Any questions you have, please ask me and get your questions cleared. Okay, it is important that you clear up your questions and any doubts you might have. Okay, so this is an opportunity. You have a time now. You can ask. Okay, you can see the notes, and if you have anything that you don't understand, that is not clear, ask me now and get it cleared. Okay, so this is a chance, because we don't get too many time slots to discuss things. So again, every now and then I try to insert some session where we can discuss things. So this is one such session where you can ask me any questions. So if you want to ask me anything, just turn on your microphone on your screen and speak to me, please. Okay, so at the bottom of your Blackboard screen, you see this microphone symbol. Please turn it on and speak and ask the question, and I will try to give a response and explain it to you. So we have another 25 minutes to have a discussion now. Okay, right. I have also posted a quiz on Blackboard. So I think you have seen the you have seen the announcement on Blackboard, right? The quiz, I think, is for next Saturday or Sunday. Check the date. I think it is posted for Saturday or Sunday. Okay, it's a short quiz of only 15 minutes, so you can do the quiz. Look at the announcement on Blackboard. It is already announced. Uh, the quiz covers all the topics from chapter 1 to 3 up to random processes, right? Up to the chapter of random processes, everything is included for that quiz. Okay. Now, one of the important things I want to tell you is the quiz is a test. Okay, and for a test means you have to study for the test before the test begins. You can't sit on the test without preparation and then you search for the answers and you want enough time to search and write. No, that does not happen, my friends. A quiz is a test, and for a test you are supposed to prepare the test before starting the test. So the quiz will allow you enough time to answer all the questions if you have prepared. If you have not prepared, and if you are spending your time searching for answers in the notebook and textbook, for sure you're not going to complete the test. You will not find the time to be sufficient. Okay, so you are not going to be allowed to have enough time for you to sit for the test without any preparation, and then you search in the notes and you have all the time in the world to search and write your answers. No, this is a test. You know how a test works, right? So a test means you need to prepare beforehand and sit for the test. Okay, guys? So if you prepare beforehand, you will have sufficient time. It is all multiple choice. You just need to select the correct answer, but provided you have prepared for the test. If you didn't prepare, then obviously you are going to be searching for the answers, and that will eat up your time. Okay? So please prepare for the test before the test begins. You have enough time. You are advanced at least 3 days or 2 days or 1 week in advance about the test. So you have time to prepare and do it. And it's only a short test, which is only 10 minutes, 15 minutes, and 5 or 10 multiple choice questions. So please prepare and do it. Right, any questions, guys?
Doctor,
Yes.
I have a question about the random processes.
Yes, okay.
What is the random processes? It's the autocorrelation, right? And the cross correlation.
Autocorrelation and cross correlation are some properties of the random process. Okay, some statistical properties of the random process, because when we say something is changing randomly, that means every time you measure it, you don't get the same waveform, right?
Yes.
The waveform may not be same, but certain properties may be similar. So the autocorrelation tells us what is the relationship between one sample of the random process and another sample, which can be a shifted version of the random process. So it's like comparing that random process at different times and see, okay, at different times, do they have the same properties or they have completely changed? So the autocorrelation tells us what is the relationship between a random process v of t and the same random process v of t at another time. I measured it today, I measure it again tomorrow, for example, right? And I want to see what is the relationship. Does it have the same properties or its properties have completely changed, right?
Yeah.
So that is what the autocorrelation tells us. And what does the cross correlation tells us? The cross correlation is between two different random processes. So I can have one random process, if I can call this as v of t, another random process, you can call it as w of t. Are these two random processes having some connection, some similarity in their properties or not? That is given by the cross correlation.
Thank you.
Right? And clearly, and if you see the, for example, the white noise, its autocorrelation function is an impulse, right? The delta function.
Yes.
So what does it mean? The autocorrelation is a delta function, means that the random process v of t and a shifted version of it has no similarity at all. If I shift it, I don't see any similarity. The similarity is present only when the shift is 0. So when that is why you have the delta at tau equal to 0.
Yeah.
For any other value of tau, the similarity becomes 0. That means they have no similarity at all, no connection at all. It's as if, if I give you an example for this, basically, for example, you are observing me and you are trying to see, okay, how is this person? How is his nature, right? You see me today and you see me tomorrow. Tomorrow I'm completely changed. I'm a completely different person that you don't even recognize who I am. I have changed so much.
It should be at the same time.
it should be at the same time. If you see me now and now, you find 100% match. But if you see me after 1 second, in 1 second I have changed completely and you don't even recognize me, right? If that sort of process is called uncorrelated process, no similarity at all when there is a shift. But if there is some similarity, that means you can predict what it will be in the future, or you can, from the past you can predict the present, from the present you can predict the future, because you know how it is changing with time, right?
Yes.
So we use this, if you remember, in differential pulse code modulation, we use the predictor. So we use the autocorrelation of speech signals to design the predictor, because the speech signals have a high degree of correlation between successive samples. The predictor is able to predict it. If there was no correlation at all, we can't predict it.
Thank you, Doctor.
Any other questions?
Thank you, Doctor.
Right, guys. We have another 20 minutes, guys. Please use this time to ask your questions and clarify all your doubts. We don't waste this time, okay? We want to use this time as effectively as possible to make your learning process as effective as possible, okay? Any other questions? Ibrahim, Ayman, Badr, Abdullah, Jubran, Abdul Rahman, Muhammad, Abdul Aziz bin Yahya.
Thank you, Doctor. Thank you.
All right, okay. So you have no questions, is it? You're welcome, my friends, okay? Guys, again, I want to emphasize, important. You must study for the quiz before you begin the quiz, okay? Okay. Please study for the quiz before you begin the quiz. If you don't study before you begin the quiz, you are going to find it difficult. The simple reason is because the quiz is a test. Okay, if you are going to sit on the test and if you're going to search in the material for the answers, you are going to take why is my screen changing? Is some of it changing? I don't know. So anyway, if you don't prepare for the test, then you will not find enough time to complete the quiz. Okay, the quizzes that you are getting have enough time, plenty of time to finish it, provided you have prepared it. If you did not prepare it, then there is not a lot I can do, my friends. All right, guys. Okay, so if you have no questions, I'll leave it at that. You can leave the session, and if you have any questions, stay online and ask me the questions that you have. I'm available here for another 15 minutes. Okay, so we have another 15 minutes remaining for this session, and you can ask me. Okay, I'm still online for another 15 minutes. Okay, but if you have no questions, you can exit the session, and we will meet again in the next lecture after tomorrow, that is. And you have a written assignment that you have to complete, and those are all direct questions which you can write from the notes. But the important thing about that is, do not copy the assignment from your friend. Okay, read the notes, read the text, and write it from the notes and the text. You will have all the information that you need to complete the assignment in the notes and the text. So just open the notes and the text, and you have all the information you need. Write it, take a photo of it, make it as a PDF, and submit it before the deadline. But do not copy from your friends. Okay, that is the most important thing. I don't want you to be copying from your friends and writing as it is without knowing what you're doing. Okay, so please do it yourself. They are very direct questions of the topics which are in the notes and in the textbook and what has been covered in the lectures. So just do it by yourself. That is the most important thing. Okay. Oh guys, is some of you making some diagrams on my screen? I think one of you has joined the session and you are making some circles and I don't know on my screen. Okay guys, then okay, we'll continue in the next lecture. Okay, take care. Assalamu alaikum.